Okay, so we're also going to be looking at hyperbolas with a center other than the origin. And that means that we're going to once again be dealing with a center of hk. And the h value is associated with that x value, and the y value is associated with the k value. So if you want to identify the center of a hyperbola, you need to take the opposite values of the h and k when identifying the center from the equation. So the hk just moves your hyperbola around the xy plane. And now, in order to find the focus, we need the center along with the c value. In order to find the vertex, we need the center along with the a value and so forth. So let's go ahead and just get into this with a couple of problems here. We want to find the standard form equation for the hyperbola whose transverse axis has endpoints at -2, -1, and 8, -1, and whose conjugate axis has a length 8. Let's go ahead and plot these points and plot points that make up our conjugate axis and try and come up with the equation based off the graph. Okay, so I'm going to go ahead and just get started with the transverse axis endpoints, which represent the vertices of our parabola. This tells me that my transverse axis here is parallel to my x-axis. That means that I'm going to be dealing with x squared over a squared. Let's figure out what the center of this hyperbola is. We know that the distance from -2 to 8 is 10, so that means I need to go a distance of 5 to find my very center. This means that my hk value is 3, -1, and if I want to find endpoints of my conjugate axis, because it has a length, I simply need to go up 4 from the center and then down 4 from the center. Alright. This tells me a and b, which means that a squared is 25 and b squared is equal to 16. So I essentially have everything that I need for the equation of the hyperbola. And we have our x squared over our a squared. We have our y squared over our b squared. And that's all that this particular example is asking. However, you knew that I was going to say that, didn't you? I want to go ahead and figure out what the graph actually looks like. So I'm going to go ahead and show you all what the graph actually looks like right now. We have our A's and our B's located, and so that means that we can identify the rectangle that shows us the asymptotes that bind the parabolas. My transverse axis is parallel to my x-axis, and this -2, -1 represents a vertex of my parabola. 8, -1 represents another vertex, and voila, there's our hyperbola. What if, however, you knew that was coming, didn't you? What if I said, what is the equation of the asymptote? We know that the equations of the asymptotes represent a line. So I write out y equals mx plus b, and I got to figure out my m and my b value. Let's go ahead and deal with the positive slope first, once again. Alright, so the slope is found with the a and the b values. So from my center, I see that I would need to go up a distance of, how far is that? We go up 4, and then we go to the right a distance of 5. So that means my slope is a 4 over 5. And now I need to figure out my b value. And it's not good enough to guess. It looks like it's going to be a -3, but I might not have drawn perfectly to scale, and I might be guessing. So I want to be absolutely certain. And so I'm going to plug in another point that's on my line. And so I'm going to plug in the center, HK. I'm going to plug that in when y is -1, x is 3, and I need to solve for b from here. Okay, so I found the equation of that asymptote with the positive slope, and 17 over 5 is 3.4. So my guess would have been wrong if I guessed -3. We're actually going through at about 3.4, -3.4. Okay, let's finish up with this last problem here. We want to find the center, the vertices, and the foci of the hyperbola. Let's start off with the center. Our center, HK. So we take the opposite of the 2. We got a -2 and then a +5. And then we have a squared is over the x squared. So that means a squared is 9. And we have the b squared is equal to 49. This tells me that my transverse axis is going to be parallel to my x-axis. Let's go ahead and plot the center and the a and the b values. And let's go ahead and get a visual of the hyperbola and then come up with the vertices and foci. Okay, so from my center, I went out 3 and to the right and to the left, and that will identify the vertices of my hyperbola. We could just see what those coordinate points are. However, if you wanted to figure out what those points are formulaically, you would need the center, and you would need to add and subtract onto your x value of your center. The y value doesn't change for the vertices. So let's see here. I would need to add and subtract 3 onto the x value of my center. So that means that I have vertices at -5, +5, and also at 1, +5. Let's find the focus points. So we need to find the c values. So I plug in a squared and b squared, and I end up with c equals plus and minus the square root of 58. And remember that the focus points are within the cup of the parabola, and our parabolas are shooting out this way. I know that because these are my vertices here, and remember that the focus points are along the transverse axis, which is right here. I need to figure out where those focus points are. What is the location of those particular coordinate points right there? I need to add and subtract once again onto my x value. So let's go ahead and do that. I take the add and subtract onto the x value of my vertex. So I take the -2 and I add and subtract the square root of 58 to find those focus points. The y value stays the same. Okay guys, I am super tired. It is Friday and it's 3:30 and I want to go home, and I'm not really here even though I'm here. Hopefully this was good enough. And if you have questions, we can talk about it this week. Okay. Hope you're having fun on the college trip, and not to make you guys jealous or anything, but we had way more fun in class. We had the most fun day that you would ever imagine. It was awesome. So awesome. We had a party with Cool Ranch Dorito chips and soda pop, and it was really neat. Michael sang a Britney Spears song on the piano, and it was really cute because the whole class kind of started singing along, and then we all broke out into this a cappella of Britney Spears, and it was really fantastic. You guys on the college trip really missed out. All right, see you guys soon. Hello, welcome to Conic Sections, Hyperbolas. In this section, we will look at the definition of a hyperbola. We will look at hyperbolas in the XY system, and we'll see their related equations in the XY system. Let's start off with what makes a hyperbola. If you take a double nap cone and intersect that double nap cone with a plane, then one of the resulting shapes is a hyperbola, where we have essentially two parabolas faced away from each other. A hyperbola has what's called a transverse axis. The transverse axis contains the focus points, which are in the cup of the parabola, and the vertices of the parabolas, along with the center of the hyperbola. Let's look at the definition. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points, called foci, is constant. So, in other words, what they're telling us here is that if we go from the focus to a point on the hyperbola, to the focus point, then if we subtract those two distances and take the absolute value of them, we will end up with 2 times a. A is the distance from the center of the hyperbola to the vertex. The hyperbola can be proved, once again, using the distance formula. So here I have the work for you. You don't have to prove it in my class, but here it is for your viewing pleasure. So, a hyperbola, we're going to look at a hyperbola with the transverse axis on the x-axis and a hyperbola with the transverse axis on the y-axis. If the transverse axis is along the x-axis, then the x squared is going to be over the a squared. And the b squared is underneath the y squared. We'll talk about what the b is in just a second. If the hyperbola has a transverse axis along the y-axis, then the y squared will be over the a squared, and then the x squared will be over the b squared. Once again, the a value is the distance to the vertex point. Hyperbola has the relationship such that c squared is equal to a squared plus b squared. And we'll be using that. We'll sometimes be given a focus point along with a vertex and be expected to come up with the equation of the hyperbola. So we'll have to figure out the b value, or we'll be given a and b and be expected to find the focus points. A hyperbola is drawn using a and b. And if you go from the very center out and make your a value, you arrive at a vertex point. The b value, you go perpendicular to the transverse axis. And what happens when you create the A and the B values on your graph, you end up making a rectangular shape, or in this case a square shape, where you can draw diagonals through, and the diagonals will bound your parabolas. They will help you to draw the parabolas. So here we have the how to come up with the equation for the asymptotes. And you can memorize those, but I think it's easiest to just look at the illustration and come up with those equations of the asymptotes on your own. Let's go ahead and get into it with example number 1. We want to find the vertices, foci, and graph the hyperbola. Well, first of all, we need to put this in the form of a hyperbola, and so that means that we need to divide everything by 36 so that we have a 1 to the right of the equation there. So here we have the equation of our hyperbola, and we want to graph this. We also want to identify the vertices and foci. I believe that it's easier to identify the different parts of the hyperbola after we come up with a picture, an illustration that helps us to understand things. The x squared is over the a squared in this case, so that means that 9 is equal to a squared and that b squared is equal to 4. I should mention that the a squared is not always the larger value like it was with the ellipses. The a squared will be associated with the positive fraction. Our transverse axis is along the x-axis. That means our vertices and foci are on the x-axis. Let's find A and B and then label some points on our graph. Okay, so finding A and B enabled me to find the points that will identify the rectangle, which will enable me to draw the asymptotes, which will enable me to draw the parabolas, which make up the hyperbola. So here's my rectangle, my diagonals, which are the asymptotes that bind the parabolas. Go through the diagonals of the rectangle, and once again my transverse axis is along the x-axis, so that means my vertex point for one parabola is here, and I'm going to go outward and follow that asymptote, and here I'm going to go outward, follow that asymptote. Likewise on this side here, here's a vertex of the parabola. I'm going to go outward towards that asymptote, and that makes up the graph of the hyperbola. We have the vertices labeled, we just need to find the foci. As you can see down below there, we have in blue how to find the focus points for hyperbolas. C squared is equal to a squared plus b squared. And so I found that C is going to give me plus and minus the square root of 13, which is approximately plus and minus 3.6, which will put our focus points in the cup of the parabola. And that means they are right here and here. And so our focus points are at plus and minus square root of 13, 0. Now, I didn't ask for it, but suppose I asked you for the asymptotes. Suppose I want to know what are the equations of these asymptotes. And we know that y equals mx plus b. So all we need is the m and the b value to identify those asymptotes. So the b value is the y-intercept, and we have a y-intercept of 0 here. Let's go ahead and identify the positive asymptote, the positive slope asymptote right now. To identify that, we have to look at the rise over the run, and that's pretty easy because we have, if I start off at the origin, I can see that I would need to go up 2, and then over to the right 3 to find another point on that asymptote. So that means that the slope is 2 over 3 times x plus 0, and that gives me the equation of that particular asymptote. If I want the other one, then I'm just going to have to write the minus also. Okay, so plus and minus 2 over 3 x represents the equations of our asymptotes. For our second example, we want to find an equation of the hyperbola with foci at 0, -3 and 0, +3 whose conjugate axis has a length 4. Sketch the hyperbola and support your sketch with a graphing calculator. Well, I recall now that we have not talked about the conjugate axis. The conjugate axis is the axis that runs perpendicular to the transverse axis. The conjugate axis deals with the b value. Let's go ahead and start off by plotting our focus points and plotting the b values based off a conjugate axis of length 4. Okay, so our focus points are at 0, 3, 0, -3. That means that this length here, c, is equal to 3, which means that c squared is equal to 9. And the b is the distance from the center out to an endpoint here. That means that b is equal to plus and minus 2, which means that b squared is equal to 4. So we have that a squared is equal to 5 based off of our Pythagorean relation. We know that for a hyperbola, c squared is equal to a squared plus b squared. So to find the a value, I subtracted b to both sides, b squared to both sides, and we have a squared equals c squared minus b squared. We have c squared, we have b squared. That means that a squared equals 5. And so from here we can write out what the equation of our hyperbola is. I have y squared over 5, which is a squared. How did I know that? Well, the focus points lie on the transverse axis, and the transverse axis then is on the y-axis, which means we start off with the y squared over the a squared minus x squared over b squared. We want to support the sketch with a graphing calculator, which means that we would need to solve this particular equation for y. So here we have our equation solved for y, and we need to plug in plus and minus the square root of 5x squared over 4 plus 5, and that will show us the hyperbola on our calculator. Let's see. Alrighty, here we have our equations in y1 and y2, and let's look at the graph. One parabola faced up, one faced down.